Okay, so here is the fifth assignment. So I'm taking you on for the fifth assignment. Okay, so here in this 5.6 question, what I've done is I've made two lists, that is X and T, and in another list we will add another value, that is another list, that is Y. Then we can use like a normal for loop to find that equation. So here is this for loop equation in this range of length of X, and for this one, this this is the function, a mathematical function cos sine x of math x exponential of 1 by t by y. So now I'm printing the calculated values using loops and this one. So now here the thing is, but in the question they've asked us to use numpy. In numpy we make an array x equals to np and then another one as t or t underscore np. So we don't use formal loop here, but we use the equation here, that is directly, and then we print this value. So the output which we get using loops and calculator is this one, using just the numpy library is this one for this particular equation, mathematical equation. Now going to question 5.7. Here we are making an array with the help of numpy. W equals to this, w equals to np of array for this one. So we create an array w with values from 0 0.1 till the value 3. Then we display the original array here, and we have done some slicing operation here. This is from backwards, this is from last but n minus 1 for this one, similarly for this one, and this is between the values of 2 and 2.6. Then here is here is the explanation which I have given for this. The entity of the array is displayed given that no distinct number start, stop or step parameters are indicated here. Here the all elements are showcased except for the final two, as this -2 is determines the stopping point before reaching the array end. And for the third one, the elements are selected and displayed at every fifth position throughout the entire array. Due to the step parameter, here we have set the step parameter as to 5. So commencing from the third element, every sixth element is displayed while omitting the final last two the elements of the array. Now we have, when we just print this explanation, so we get this value. So here you can see this value of this one after the slicing is done here from the fifth element, this one. Okay, now going to the 5.818 question. So since I don't have that text file, so I've created a random data of years and months here, that is implemented in this section 2.6.2. Okay, so the thing is, here we are taking a file and then taken a random data and then we perform the operations, such as here this is the sample data of year, months with the random sun hours. So this is the one. So we will set results of January, February, March, April and for the whole year, and then we have taken it for a decade as well. So this is for and then we have taken this one and there we have taken the pi average of that value as well. So here you can see this is for the full decades value of data we analyze like this, and here we have calculated the average share before this one. So here are the outputs for months, and this is for from January to December for the whole year, for months, for each month. So the month with the best weather here. So this is what we get the output here. Average sun hours from January to December, we get this one. And then with the best weather is what we found out is we can find out from this particular equation is like it is from December. So this is the average value for decades. I have taken for 7 decades, that is from 1929 to 1999 we have taken. So this is a start here for each decades. So here we get this value as for each of these decades average sun hours is this one, and for each one of them the thing is I can get